Okay, guys, let's get started with the Math 1325 final exam review. So here we are given this graph to work with. Let's make it large. And part A is asking for the limit of f of x as x approaches 1 from the negative direction. So we're approaching the value of 1. We're coming in from the negative side, and this y value here is 0. We are on the x-axis, okay? So that's part A. Part B is asking us the limit as x approaches 1 from the positive side. So we're doing the same thing here. We're coming in from the positive side. X is 1, y is 0. Y is approaching 0, the limit, okay? Then part C, same thing. As x approaches 1 from both directions, the value of y is approaching 0. And then finally, part D, f evaluated at 1 is equal to 0. So again, this is pretty much interpreting the graph. And if you want to, you can make a quick sketch on your test notes. This is your x-axis. The graph is coming in at 2, 1, 2. It drops down. There's an open circle. We have this portion. So you can show, let's see, this is 1. So it approaches from this direction. The limit as x approaches 1 from the negative side. And then you can do something like this. I mean, if you're good at interpreting this, right, this is final exam day. So we want to be mindful of our time. But that's a good way, really quick, to show how you got your values. All right, let's move on to question number 2. Okay, moving on to question 2. Let's zoom into the graph again. Part A, for this function, what is the limit as x approaches 1 from the negative side? So again, we're going to follow the function from the negative side as it approaches 1. The value here is approaching a value of y equals 4. So that's what we're going to input here. All right, part B, the limit as x approaches 1 from the positive side. So we're following the function as x approaches 1 from the positive side, and here the y value equals 2. And part C, what is the limit as x approaches 1? Well, we see that there's a discontinuity between the limit approaching from the negative side and the limit approaching x equals 1 from the positive side, so the limit does not exist. There's a discontinuity at x equals 1, or as the limit approaches 1. And so then finally, part D, f evaluated at 1. The closed circle is here at a y value of 2. Okay, that's everything for problem 2. Problem 3, find the limit if it exists. Okay, so now essentially we are, this is just, problem 2 is just graph work. Problem 3, we're given the function, find the limit as x approaches 3 of x times x minus 5. Okay, and so if we break this down, we can break this down into unique parts. So the limit of x times the limit of x minus the limit of 5, and these are all evaluated as x approaches 3. Okay, so that's part A. And then part B, we're simply evaluating this function as the limit approaches 3. And again, if we wanted to graph this, we can just plug that into our y equals, so x times x minus 5, graph that. Let's zoom out a little bit. Let's make this negative 20, 20, negative, do negative 50 and 50. Okay, that's what our graph looks like. There's not any discontinuities. It's just a parabola. So we're simply going to evaluate this function at x equals 3. And again, we can do that in our graph. Y equals, I'm sorry, second trace 1, x equals 3. Enter, your y value is negative 6. So this limit as x approaches 3 for x times x minus 5 is equal to negative 6. And you can also just do that by calculating longhand, right? So 3 times 3 minus 5, which is going to give you 3 times a negative 2, which is negative 6. Okay. Question 4. We are evaluating the function f of x equals x minus 4 divided by x squared minus 4x. So the first thing we want to do here is factor an x out from our denominator. So x minus 4 over x times x minus 4. So that leaves us with 1 over x. This factor is going to cancel this factor. Okay, so now let's look at part A. So part A is evaluate f of x as the limit approaches 0. Oh, I wrote that real messy. The limit of x approaches 0. What is this going to equal? That's going to be 1 over 0, which means the limit does not exist. The limit does not exist because we cannot divide by 0. Okay, so then same thing with part B. We're going to evaluate the limit as x approaches 4. So 1 over x, that's going to give us 1 over 4. And then finally part C, the limit as x approaches 16 equals 1 over 16. All right, that's it for problem 4. Let's keep going. All right, now problem 5. We have the function f of x equals 4x squared minus 23x minus 6 over x squared plus 13x minus 114. So we're going to factor both the numerator and the denominator. That's going to give us 4x plus 1 times x minus 6 over x minus 6 times x plus 19. The x minus 6 factors are going to cancel. So we're left with a simplified function f of x equals 4x plus 1 divided by x plus 19. Okay, and that's what we're going to use to evaluate our limits in parts A, B, and C. So for A, we're evaluating the limit as x approaches 6. So that's going to give us 4 times 6 plus 1 divided by 6 plus 19. That's 24 plus 1 gives us 25 over 25, which equals 1. All right, part B, the limit is approaching 0. So 4 times 0 plus 1 over 0 plus 19 equals 1 over 19. And then part C, the limit approaches 1. So we have 4 times 1 plus 1 over 1 plus 19. That's going to give us 5 over 20. We're going to simplify that and reduce our fractions. So that's going to give us 1/4. All right, that's problem 5. Question 6, let's zoom in our graph. Okay, so now we're just interpreting, okay? So we want to interpret this graph for the limit as x approaches positive infinity. What is the value? What is the limit approaching? Okay, so we're going to follow our graph as our x continues all the way to positive infinity, this direction. What y value is the graph approaching? The graph is approaching a y value of -1. Type your value in, and we are done with number 6. Okay. So let's move on to number 7. We have find the indicated quantities for f of x equals 4x squared. Okay, we want to find the slope of the secant line through the points 1, comma, f evaluated at 1, and 1 plus h, comma, f evaluated at 1 plus h. Okay, so let's set that up. Okay, so the first part is find the slope of the secant line through the points. So let's set up our work. We are going to calculate 4x plus h. No, we're going to do 1 plus h squared minus 4, 1 squared divided by h. And that's going to give us 4 times 1 plus 2h plus h squared minus 4 over h. We're just going to keep distributing. So 4 plus 8h plus 4h squared minus 4 over 8. And then 4 minus 4, those are going to cancel. So now we're left with 4h squared plus 8h divided by h. We're going to reduce each term. So this is going to leave us with 4h plus 8. Okay. And now we want to find the slope of the graph at 1, comma, f evaluated at 1. So in order to do that, we're essentially going to just take, give me 1 second. We're just essentially going to take the limit of the slope of the secant line as h approaches 0. So the limit as h approaches 0 of 4h plus 8. So that's going to give us a value of 8. Okay, so that's part B. Now part C, we're asked to find the equation of the tangent line at x equals 1 and whatever the corresponding y value is. Okay, so the first thing we're going to do is come up here, back to our original function, and plug in x equals 1, which is going to give us 4, 1 squared, which is 4. So our point is 1, comma 4. And that's what we're going to use in this part C, okay? So we want an equation of the tangent line. We know our equation is y minus y1 equals mx minus x1. The slope that we're going to use is, of course, the slope that we calculated in part B, which is 8. Okay, and we're using our point 1, 4. So y minus 4 equals 8x minus 1. That's going to give us y minus 4 equals 8x minus 8. We're going to move this 4 to isolate the y variable. So that's going to leave us with 8x minus 4. And that's the equation of the tangent line at x equals 1, f evaluated at 1. Okay. Question 8. Find the equation of the line tangent to the graph of f at x equals 1. Okay, so first we are given the function f of x equals 2 plus 3x times 3 minus 2x. Okay, so first thing, let's you can do this either using your product rule or distribute and then find the first derivative. Let's do some algebra just because I know we're going to be using a lot of these skills later. So I feel like maybe seeing them again and being reminded of distributing and collecting like terms will serve us later on in the review. Okay, so distributing 2 times 3 is 6 minus 4x plus 9x minus 6x squared. Collect like terms, 6 minus plus 5x minus 6x squared. Okay, and let's just rewrite this in order of decreasing variables. Okay, so minus 6x squared plus 5x plus 6. Now let's take our first derivative. That's going to be negative 12x plus 5. Okay, so this is the first piece of information that we're being asked for, find the f prime or first derivative. Okay, so now come back to this and let's evaluate at x equals 1. And that would give us 2 plus 3 times 3 minus 2. That's 5 and 1. So our point is 1, 5. Okay, and so again, we're going to need to use this information for our x1, y1. Okay, so now we also need to evaluate our f prime at 1. And this is going to be negative 12, 1 plus 5. And that's going to give us the slope at f prime evaluated at 1 is equal to 7. Negative 7. Excuse me, negative 7. Okay, so now I have my slope. I have my point. And for the last part, I need to find the equation of the line tangent to the graph. So y minus y1 equals m x minus x1. We know our y1, our x1, and we know our slope for the tangent line. So y minus 5 equals negative 7, x minus 1 equals negative 7, x plus 7, y minus 5. We're going to move this 5 to the other side of the equal sign. So y equals negative 7x plus 12. Okay, moving on to question number 9. Okay, an object is dropped from a tower. We're given the object's height above ground, x seconds after the fall, is given by function s of x equals 1296 minus 16x squared. How long does it take the object to hit the ground, and what is the object's velocity at the moment of impact? Okay, so okay, so at the moment that it hits the ground, the height s of x is equal to 0. So equals 1296 minus 16x squared. You're going to solve for x. So 16x squared equals 1296. Divide both sides by 16. X squared equals, see, 1296 divided by 16 is 81. Take the square root of both sides. X equals plus or minus 9. We're dealing with real world conditions, and X is your time, and time cannot be negative, so X equals 9. Okay, now part B, what is the object's velocity at the moment of impact? Now you guys have already learned how to take the first derivative. So the velocity is the first derivative of your s of x function, okay? So 1296 minus 16x squared. Find the first derivative. That's going to go to 0. It's constant. So you're going to have negative 32x. You're going to now evaluate s prime of x at 9. And that's going to give us negative 288. Okay, so it takes 9 seconds for the object to hit the ground, and the object's velocity at the moment of impact is negative 288 feet per second. Okay, let's move on to question 10. Okay, the total cost in dollars of producing X food processors is represented by the function C of X equals 1500 plus 70x minus 0.2x squared. Find the exact cost of producing the 21st processor. So what we're going to be looking for is C of 21 minus the cost of the 20th. So that gives you the cost of just producing the 21st unit. Okay, so, right, test strategies. I'm actually just going to go ahead and type this function into my calculator. So 1500 plus 70x minus 0.2x squared. Enter. I'm just going to go second. Trace value. I'm going to calculate when x is 21. Well, it doesn't like that because I have to adjust my window. Okay, second trace 1. I want to know the value at the 21st unit, and that's 2881.8 minus, so I'm going to do the same thing, second trace number 1, and I'm evaluating when x is 20, and that's going to give me 2820. So I'm just going to subtract those two values. 2881.8 minus 2820, and that's going to give me 61.8. So that's the exact cost of producing the 21st food processor. It's not the collective cost of producing all 21, and I don't want the collective cost of producing 20 units. I want the exact cost of producing just the 21st unit. So I take the cost when all 21 units are produced minus the cost when the first 20 units are produced. Okay, so now part B, using the marginal cost, the approximate cost of producing the 21st food processor is, so we're going to marginal cost, again, remember that that is C prime. So we need to take the first derivative, constant goes to 0, and we have 70 minus 0.4x. We want the marginal cost of producing the 21st food processor, so we evaluate this function at the unit prior. So we'll evaluate C prime at the 20th unit. So 70 minus 0.4 times 20, and that's going to give us a cost of $62. Okay, that's question 10. Okay, so we're going to do this review in 10 question segments. So this is the end of part 1 with questions 1 through 10. If you need any help or need further explanation on any of these problems so far, feel free to send me an email and let me know if there's something else I can explain in greater detail. And as always, good luck, guys.